going to talk about another part of probability called the fundamental counting principle of probability. That is, if we want to perform a series of tasks, the first task can be done in A ways, the second task can be done in B ways, and the third task can be done in C ways, and so on. Then all the tasks can be done in A times B times C times however many ways that we have. So let's look at an example. An ice cream shop, they have 5 different flavors of ice cream, and you can pick one of 4 toppings. How many choices do you have? Well, you have 5 choices of the flavors of ice cream, and you have 4 different choices of toppings. So how many different combinations could possibly be made from that ice cream? You would take 5 times 4, so the number of flavors times the number of toppings, to find out that there's a possibility of 20 different combinations of ice cream that you could get from that ice cream shop. Now, how many ways can you flip a coin? Well, we know when you flip a coin, you can get heads or tails. So the first time you flip the coin, you have 2 possible ways. The second time I flip a coin, I still can get heads or tails. The third time, I can still get heads or tails. And the fourth time, you can still get heads or tails. So you can get 2 ways every time you flip a coin. So if I wanted to know the total possible outcomes of flipping something 4 times, I would have to do that the 4 tasks, there's 2 possible ways for each task, multiply them together. That would mean there could be 16 different combinations. And we saw this sometimes when we did tree diagrams, getting them out and writing them all out, but this is just a shorter way to do it. Here's another one. Someone wants to know how many different outfits they can make with 3 coats, 5 pants, 7 shirts, and 4 ties. Now, they have how many of each? Well, if you look, they have 3 coats to choose from. They have 5 pants to choose from. They have 7 shirts to choose from and 4 ties to choose from. Those are all the possibilities that they have. If we multiply them all together, the number of coats times the number of pants times the number of shirts times the number of ties, they have a possibility to make 420 different outfits from those clothes in their closet. So when you tell your parents you have nothing to wear, think of how many combinations you can make of different outfits. Here's another one. A useful way to keep track of different numbers of ways to each do tasks is by doing a slot diagram. So they go ahead and they write them out by the first task, the second task, the third, the fourth, the fifth, the so on and so on. However many tasks that you possibly have. And remember, we're going to multiply the total number of outcomes for those tasks. Now, the combination for a keypad is 5 digits long. Suppose that you you can use any digits from 0 to 9 for the numbers. So how many possible outcomes we could have? Well, for the first task, you could have 10 digits. You could have a 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. You could have the same thing for the second number, and the third, and the fourth, and the fifth. That means you have 10 possibilities. So if you had a keypad with 5 digits possibility, the total number of combinations that you could come up with was 100,000 different combinations for that 5-digit keypad that you may have. Think of those keypads if you have like one on your garage door. Some people have keypads on those. Those are the type of things that we're talking about. Now, the license plates. We all see license plates on cars, and no car has the same license plate. The license plate has 3 letters followed by 3 numbers. So how many different combinations could you make? Well, there's 26 numbers in the alphabet. 26 letters in the alphabet. And for numbers 0 through 9, there are 10 possibilities. So for the letters, you would have 26 times 26 times 26 because there's 3 different letters on your license plate. And for the numbers, you would have 10 times 10 times 10. So that means that the number of possibilities when you multiply them all together would be 17,576,000 different combinations for license plates. Now, here's another example. If the license plate has 3 letters followed by 3 numbers, every letter and number must be unique. That means they must be different. So that means I cannot reuse them. So the first time I do a letter, I would have 26 options. But the second time, I would only have 25 because I used a letter and I cannot reuse it. So the third time, you would have 24. The same thing would go with the numbers. The first time, you would have 10 options of numbers, but you've used one. So now you only have 9 to choose from. And the third time, you only have 8 to choose from. That's what they mean when they say they must be unique. You cannot reuse them. And that we would be able to figure out the total from that. So if I multiplied that together, sorry, my screen didn't work there. So I'm going to go ahead and multiply it out for you. If you take your calculator and you multiply out 26 times 25 times 24 times 10 times 9 times 8, you're going to find out that the total number of combinations that you could get would be 11,232,000 different combinations that we would be able to get. Give it a try. Make sure you look at the number of tasks you have and you look to make sure you don't have that unique word. If you have that unique word or you cannot reuse something again, you must adjust for that. Otherwise, you can always reuse things.